parallel lines are a pair of lines that have special properties. Can anyone tell me what they know are parallel? Yeah.
They
About
never
them.
touch.
Great. That's actually the last one I was going to say for, but
They're always the exact same distance from each other.
oh, you've got them all, Will. It's always the same distance. So write these if you didn't get them. Always the same distance apart, maybe you want to say. Okay. They never touch, or actually, there's a mathematical way of saying that. We'll say they never intersect, so they'll never cross. And I guess the last thing is, if we're thinking it from the perspective of coordinate geometry, Reeser actually told us, in coordinate geometry, what did we say they have the same of? Same gradient, that's right, James, well done. The same gradient. Okay? So that's sort of three ways of representing parallel lines. They always have the same distance apart. In coordinate geometry, they have the same gradient, the same steepness, right? And they never touch or intersect. Although, in saying that, there is a situation where parallel lines touch, which may not seem to make sense, but what have I got here? A train tracks. And what does it look like they do at the end? Train tracks are parallel, obviously, because the train has to drive on them. But what does it look like my train tracks are doing at the end over here? Yeah, it looks like that, right? And it's all about, exactly right. It's all about the perspective. It looks like that they are touching, but it's the angle of the shot that sort of creates this illusion that they touch. We know that if we actually walked along the train tracks, they would never touch at the end. Otherwise, that would... Yeah, it would be probably you'd probably be arrested for walking on the train tracks, and also it wouldn't be very good for a train if they drive along train tracks that actually meet, right? Alright, so here's how we can think about it. If two lines, and in mathematics we like to name things, right? So L1 and L2. If they are parallel, you might want to box this up for me because it's quite important. So I'm going to actually box this up for you. If two lines L1 and L2, so we're just calling them lines, right? If they are parallel, then they have the same gradients, right? So same gradients, remember, means that they're parallel. We looked at that earlier. The other thing to think about is, okay, how can we look at that? Well, Bree realized that the gradient is 1 in that previous one, right? And so M1 is equal to M2. Remember, M is just talking about the gradients of each line, right? Because we have two lines now, we typically don't like to use just M. Remember, M1, M2 doesn't mean squared or anything like that. We're just distinguishing between the two M's there, okay? So jot that down for me. Right, so in these questions over here, we're just having a look at these. We want to identify whether these lines are parallel or not. What's the key thing to look at? Remember, in your equation of a line, it's y equals to mx plus c. And which part is the gradient? Well, it's the thing in front of x. So as long as these are the same, these numbers here, then they are parallel, right? So this first one, yep, they are parallel. Right? What about this next one, though? Look carefully. No, why not, Toby? Yeah, so actually, we'll look at what that changes, but let me just get out of that for a second. I'll go back to it. But y equals to half x plus minus 1, sorry. Y equals to minus half x. Oh, that's something else, we'll talk about that later. Plus 2. So remember, what does the gradient do? It changes the direction as well. So you've got the negative of the same gradient, it's going to be sloping down from left to right. Yeah, so that's how it would change. So in this one, they are not. Okay, this one's weird. Because, what do you notice about part 3 compared to the other ones?
3y.
Yeah, so 3y there, it's not in this form that we're used to seeing. It's not in this y equals to mx plus c form. So what we need to do is we need to be a bit creative. We need to actually rewrite this a little bit so that it's in this form. Because we can't just look at the number in front of x. That's the thing. You can't just look at the number in front of x. It has to be, and we call this the point gradient form. So point gradient form just means in this form over here, if we want to know what the gradient is. So, how can I make it so that y is just having a coefficient of 1? So y is just sort of by itself on the left-hand side. I might need to do divide by 3. Divide by 5, that's right, Will. And what do I get for that? Yeah, 3x. Yeah, 3x plus. Now be careful because remember we have to divide everything by. Good stuff, Lachlan. The 3x plus 1. So these ones, they are parallel. Because they are the same. These two here. Last one, have a think carefully about this one. Have a think carefully. Yeah?
For the one on the right,
Yep.
x is pretty much just 1,
Okay.
which is 1 over 3, and the one on the left is 1 over 3 times 1, which will still be 1 over 3.
Let's have a look. So, the easiest way to check, right, what Toby's saying is, so Toby's saying, hang on, you're saying that these two are the same, is that right?
I think.
You think? Okay, so let's have a think. Let's pick a number to check whether this might. Can you, Annabelle, just give me a number between 1 and 10? 5. Alright, so let's use 5. And let's check. Is 1 over 3 times 5 the same as 5 on 3? So let's put it in our calculator. So 5 on 3 as a decimal, 1.6666. 1 over 3 times 5. And we get the same thing. So if you remember from your fraction multiplications, these two are actually the same, right? Because you can just write x on 3 as 1 over 3 times x plus 2. They are the same. And since the gradients are the same, the number in front of x, they are parallel. Okay? So these two are the same. These two have the same gradients, so they are parallel. All right. Any questions about that so far? Yeah? Now, a bit of harder question. I'm not too sure if I want to go through it just yet. Instead, I want to go straight to this one over here, right? So, perpendicular lines. Anyone heard of the word perpendicular before? Straight, you reckon? Yeah? Maybe 2 straight lines or something? What do you reckon?
2 lines meeting at a right.
Good. Perpendicular lines are when they meet at a right angle. You might remember that from geometry. They meet at a right angle. Now, if you want to think about what perpendicular lines would look like on a Cartesian plane, it would look something like this. So this is my Cartesian plane here, x, y. I'll zoom out a bit. And if I had 2 lines, maybe going like this and like this, they would meet at right angles, like so. The question, I suppose, then, is, okay, sure, they can meet at a right angle like that, but how does that actually affect what this is going to look like for my graph? So I'll go back to that in a second. I'll go back, but just watch up for now. If I want to look at perpendicular lines, this is the situation we've got here. And I want to choose some nicer numbers to make this a bit easier. But right now, this is an example of 2 lines that are perpendicular. Y equals to x and y equals to minus x, right? Let's try and make this a bit different. Let's make it 2. So now we have y equals to 2x. What's the gradient of this one, though? Negative 0.5. So let's write this down. So we've got 2, and then the perpendicular thing, this is the symbol for perpendicular, negative half, or no, negative 0.5. Let's try 3. Let's see what happens with 3. So when I have a gradient of 3, what happens? What's my new gradient for the perpendicular? Yeah, negative a third. Interesting. What do you think might happen with 4? Let's have a look. Exactly right. How could you describe that? What's happening? Yeah? What do you think?
When you multiply it together.
Yeah. So when I multiply these two together, so first of all, this number's smaller, right? I agree. And we multiply these together, what do you get?
1.
Negative 1. Good. So 4 times negative a quarter. Negative 1. 3 times negative a third. Yep, negative 1. And last one to check. 2 times negative half. Yep, negative 1. So, what's our relationship? Our relationship is actually this. Can you jot that down for me? Two conditions. Either, if they're perpendicular, either you can think about it as, okay, when you multiply them together, you have to get negative 1 for the lines to be perpendicular. Or, you can... So I'll say that again. Perpendicular lines, for them to be perpendicular, you need some certain conditions, and here are the conditions, right? You multiply them together, and they have to be negative 1. Or, or you can think about it as putting it on the bottom of a fraction, and then getting the negative of that. Right? Let's look at these two. Identify if the following are perpendicular. So how can we check? Well, as long as they meet this criteria from up here, and we can check either way. We can multiply these two numbers together, or we can actually check if they're on the bottom of a fraction and then made the negative of that. What I'll do is I'll actually check on the calculator, because I like checking on the calculator. If I multiply these together, you notice we do get negative 1. So they are perpendicular. What about the next one, do you reckon? Half and negative 2. How can we check? Let's get the calculator out. Oh yeah, and you want to write it like this, you mean? Yeah?
Is that not allowed?
Yeah, it depends. You'd have to be a bit careful. You have to be the right context. If you're using words, generally words, this is generally more for like, if you wanted to say like two lines were perpendicular, you could write it like that. L1 is perpendicular to L2. But for this one, you can't just write they are perpendicular. Yeah. What about this next one? Can someone put in their calculator for me? Put in half times negative 2. Just double check for me. Does it equal negative 1? Yeah. So they are perpendicular. That's fine. And in your calculator for me, who's got a calculator actually? Monique's got one there. Could you put in 3 times 0.3 for me? Oh yes, actually you might have noticed actually it's not a negative, but let's just double check anyway. 0.9. Okay, cool. So they are not perpendicular. Right. So that was a terribly drawn perpendicular. Right. Alright, what I'm going to do, I'm actually going to stop there. I actually have a few more questions I want to go through, but I want to give you time to do exercise as well.